let's talk about plotting linear graphs. Now, a lot of you might already be very familiar with this, but this can be a bit of a reminder. So, the first thing is we have a Cartesian plane. Now, what is a Cartesian plane? Got a little example of it here. This is what we show graphs on. It is divided into 4 quadrants. So quadrant 1, 2, 3, and 4. And see how it goes round in that anti-clockwise direction. Okay. And of course we've got our y-axis and our x-axis. Our y-axis is our vertical one. Our x-axis is our horizontal one. So every point is described using a pair of coordinates that describe its location. The coordinates are x, y. All right, it's always x first, then y. It's always that order. Okay, so you can see here on this little example that dot is at coordinate 3, 2. So the x value 1, 2, 3, and y value 2, 1, 2. Now, if you remember, that spot there is where x and y equal to 0. And we call that the origin. But you've got to remember that that's where x and y equal to 0. I like to imagine that x is a number line and y is another number line. But yes, we've got coordinate points that describe every single location on a Cartesian plane. Now, a table of values is what we use to show a set of points that are linked with a rule, or in other words, an equation. Okay, so we use a rule or equation to link x and y, okay, and we have these sets of points. Now, you can use whatever values of x you want, okay? There's no set rule of what value of x you use here. We usually, though, would choose 0. It's a really good and important spot on any graph where x equals 0. So we'd usually pick that one, and then a few below and a few above that. And that's what we do here. So I've just got -3 to 3. So if you're not told specifically which numbers to use in your table of values, that's a pretty good, just set of numbers to use. Okay, so let's look at this. We've got y equals x plus 3. So this first one, x is equal to -3. So I sub it into our rule, our equation. So -3 plus 3 equals to 0. So y equals to 0. Here, our second value, x is equal to -2. I sub it into the equation. -2 plus 3 is -2 plus 3 is 1, isn't it? -1. X is equal to -1. So I substitute it into here. So y equals -1 plus 3. So y equals to 2. Here we've got x equal to 0. So y equals to 3. Okay, x equals to 1. So 1 plus 3 is 4. X equals to 2. So I substitute it into here. So y equals 2 plus 3 is 5. And here, 3, 6. All right. So let's look at this next rule. 2x minus 1. So y equals 2x minus 1. So with substituting the value for x, and that will tell us what that y value is at that value of x. So I've got x equals to -3. So 2 times -3 is -6, minus 1 is -7. So x equals to -2. So 2 times -2 is -4, minus 1 is -5. Okay, so y equals 2 times -2, so that's -4, minus 1 gives you -5. So x equals to -1. 2 times y equals 2 times -1, so that's -2, minus 1 is -3. So x equals to 0, so y equals 2 times 0, so that's 0. So y equals 0 minus 1, -1. X is equal to 1, so that's y equals 2 times 1, which is 2, minus 1, which is 1. Okay, x equals to 2. So y equals 2 times 2, so that's 4. Take away 1 is 3. And x equal to 3, so that's 2 times 3 is 6, minus 1 is 5. So we can plot a graph from a table of values. Now, plotting is a skill. Plotting is where we show every point, okay? Show every point. Later on, we're going to be doing something called sketching. And that's where we're not having to show every point. But it's very important for you to know that if you are asked in a question to plot something, you have to show every point. So you start with like a table of values, and then you plot on the Cartesian plane, and then you link those up with a line. So if the graph forms a straight line, we call it a linear graph. And so then that rule is called a linear equation or a linear relation. You probably remember that from earlier in the year. So when we draw a linear graph, we need a minimum of 2 points. Okay, and usually if we're sketching, we'll just use 2 points. Plotting, we'd have to show every point. Now I'm just using our values that we got earlier. So y equals x plus 3. So this is where, you with your being able to use a ruler really helps. Well, you have to use a ruler here, but it's a bit difficult on an iPad to do that. So I look at this and go, okay, my x values are from -3 to +3, so I have to make sure my Cartesian plane will show at least that. My y values are from 0 up to 6, so I have to be able to show at least that. Okay, so let's draw that. Why didn't you go straight? Okay. Yep. Okay. So you can probably start to see why having a ruler is so handy. Okay, y-axis and x-axis, and you absolutely have to have the arrows at the end of the axes, and you have to label what these are, so y and x. Okay, now this is where you should get your ruler out so you can space these out evenly. because especially with plotting, these have to be very even so you can see it clearly. Oh, what have I done? Okay, now if I was drawing this in my exercise book, I might use, the centimeters to show my X, and my Y, I might use the, the lines on my exercise book to help guide me. Okay. Alrighty. Now, I'm going to plot some points. Now, to make it clear, I might do this in another colour. So my first point is -3, 0. -3, 0. So that is here. -3, 0. -2, 1 is there. So -2 up 1 there. -1, 2 here. 0, 3 there. 1, 4 here. 2, 5 there. And 3, 6 there. And you can draw, oh, I'm not drawing a very straight line. I might redraw that. But you can see why making sure you're using a well-measured, well-scaled graph or lines here is very important, okay, because you need it for your graph to be exact. Okay, and we can continue that on a little bit, but really that's what we show. And also next to that I write the equation, so y equals x plus 3. So here I've got y equals 2x minus 1 as the equation, and I've got the table of values there. On my graph, I have to be able to show all of these points. Okay, so let's sketch this up. So we start by drawing up the axes. That's a bit wonky. Okay. I'm not doing a good job with straight lines today, am I? It's much easier if you can use a ruler, which of course you all can in your books. I'm really struggling. There we go, that's a bit better. There. Y, X. Okay. And -1, -2, -3, 4, 1, 2, 3, 4. Okay, oh, I don't think I've gone down far enough, so I might need, after all of that, okay, so 1, 2, 3, 4, 5, 6. So -1, -2, -3, oops, -4, -5, -6, -7. Okay, so my first coordinate point is -3, -7. So that's roughly here. Then I've got -2, -5. So I've got that there. -1, -3 here. 0, -1 is on the line where x is equal to 0. 1, 1, it's about there. 2, 3 here, and 3, 5 there. That's not too bad. And then, yes, I write the equation next to it. Now, sometimes you have to prove if a point lies on a line or, lies on as part of a graph. So let's do an example of that. Does point 2, 4 lie on the line given by? Okay, so I have this equation here, y equals 3x minus 2. Does that point lie on that line? Well, I'm going to sub in that point. Okay, so x equals 2, y equals 4. I'm going to substitute that into the equation. So where I've got y, 4, 3 times 2 minus 2. Okay. So that's 4 equals 3 times 2 is 6 minus 2. And there we go. So left-hand side equals right-hand side. So yes, 2, 4 lies on the line y equals 3x minus 2. Okay, so now I've got y equals -x plus 5. So I'm going to sub in to 4. Okay, so 4 equals -1, I'll just write it in for now, times by 2, plus 5, because remember that negative in front of the x means -1 times by x. So 4 equals -1 times by 2 is -2 plus 5. So -2 plus 5 is 3. So 4 does not equal 5. So these two sides are not equal. So no, that point does not lie on the line y equals -x plus 5. Your book also shows slightly different way of doing this, where they just substituting x and so look through that. But this is really the way of doing it, is you see whether in substituting in that point you get a true statement at the end. This is true, this is not true. So as this is true, if you substituted this point in, yep, that works. They are connected by this rule. But this doesn't work, so these 2 points are not connected by the rule, so it does not lie on that line.